I'm Kellen.
And I'm Jesse.
Our third team member, Connor, is in California, so is not joining us on this video. We started this project very excited to design a new approach to solve this problem. We decided to go with a slightly different methodology than we think others might include. Instead of trying to mitigate bias by changing thresholds or altering model performance, we're instead placing a confidence interval on the model output. We think this not only is a novel and a different approach, but it can also work in tandem with other participants in current research being done in bias mitigation techniques.
So the problem that we're addressing with MLPE is physician confidence in model performance on an individual patient level. So once a model has been finalized and decision thresholds have been set, how can clinicians trust that the patient that they're using it on is in domain and that the ML model is anticipated to have the same sensitivity on that patient as it had for other patients that they saw earlier that day? In fitting, MLPE captures underlying demographic related feature differences, which may be due to demographic correlated features, latent or lurking variables, or even hidden stratification amongst the labels. And then MLPE is able to apply what it learned about model performance across feature space to new patient records. So the tool also is able to list intersections of demographics which perform especially poorly in terms of model sensitivity or specificity. And that can enable the researchers to identify subpopulations which may benefit from increased sampling, increased labeling, or even additional models or experiments to determine why model performance isn't up to par.
Yeah, we are so excited about this methodology. Not only do we think the math behind it is really cool and exciting, but we're also looking forward to interacting directly with physicians to build confidence in these techniques that can really make a difference.
So let's show you an example of how it works. So here's an example Jupyter notebook that we set up in order to demonstrate use of mitigate disparity and measure disparity. First, we're going to import the functions as well as a prepare example data set that module that we set up on the Cynthia COVID data set that's synthetic data recommended by ExpeditionHacks. So what we're doing here is we're taking the first 10,000 records and using our mitigate disparity fit function on it. And what it's doing here is balancing the data set in terms of demographic attributes. And here we are finding our pairs for metric learning. So metric learning runs, and what this is doing is stretching feature space in a linear transformation based on the various demographic attributes and subgroups. And then we can see our Earth movers distance here of the test set versus a confidence interval bootstrapped on the training set. It's a little bit outside, but nothing of concern, as long as the researcher knows that those are slightly different populations. And then once we've calculated our lattice scores, we can look at feedback to show attribute subgroups and their various confidence intervals. And here we are predicting new patient data on everything after those first 10,000 records. We see that there's over 2,000 and different confidence intervals predicted on them. And then here is measure disparity, where we can look at various demographic subgroups in a new data set.